get started. So
Go ahead.
Mehul Bhuva, as I said, yep. So Mehul Bhuva, I'm a data architect at QCI. It's a local company in Des Moines, Iowa. And then been working with Microsoft for Microsoft Technologies for 20 years, as I mentioned. Started with VBASP, graduated to C#.NET, and then all the other patterns, frameworks, WPF, WCF, MVC, LinkU, .NET Core. Mostly have been an application developer, senior software engineer, tech lead, filled multiple shoes, worked on SharePoint as well for a bit, consulted in Michigan for GM in 2010, 11 timeframe. Worked for Amgen as a consultant, as a SharePoint technical consultant, then switched gears and moved to Microsoft Azure platform. Now I'm a data architect, so it's just, it's a lot of stuff to keep up with. But working on Databricks currently and Power BI and reporting for a client here in Des Moines, Iowa. I'm sure everyone has heard about Power BI, and a few have got a chance to work on Power BI as well. If you know the traditional Power BI reports, the way we have been used to working with it is in the PBIX format. To show you, just quickly switching gears here, this is how a PBIX file looks like, right? Assuming this is just a sample file that I've downloaded from Microsoft. This is all bits, right? It's all zeros and ones for us. It's all garbled text, but essentially it's the way Microsoft started off, and these files are not very meaningful when you look at their source code. And they are not, and it's difficult to deploy them across environments. There is an out-of-the-box deployment pipeline, but it's all manual still. So there are a lot of pain areas associated with PBIX files, right? They have one big gigantic file with all the visualizations, queries, data, things like that. Now, automated deployment pipelines for PBIX involves several steps, right? Extracting the PBIX file from source control, validating the PBIX file to ensure it meets quality standards, deploying the PBIX file to a Power BI service through your workspaces and the apps, and then monitoring the deployment process and handling errors. This is all a manual process. There is a lack of version control in the workspaces. So you deploy the file, your developer who is working on a Power BI report deploys the report and leaves the company, and let's say deletes the file from the workspace before leaving the company, you have no way to retrieve that report back. So if the report gets deleted, there is no way to retrieve it back. Now, what Microsoft has done is very smart. They have done something which is enabling the premium features. If your workspace has a premium feature, you can connect it with the Git repository. So there is a workspace integration, which is, but then you have to pay $5,000 to $10,000 a month extra for a premium license. So that is another pain area, and most people don't want to pay for that kind of a license, which does not add a lot of value to, in my opinion. Of course, backing up should be automatic, but it's not. Version control is not automatic either. And the manual deployment process is pretty cumbersome. So right now in the current company, that I work for, I consult a client here. So they have around 5,000 different or 13,000 different workspaces across the board, and they all use PBIX. None of them is version control, source control. Right? They deploy the files from dev to test to prod. Sorry, not the files, but reports from dev to test to prod. And their deployment process is pretty much manual right now. Some of them have switched over to the out of the box deployment pipeline, but a majority of them are just going from one environment to the other by renaming the files, report underscore dev, report underscore test, report underscore prod, and they also make changes to the database connection strings manually, which is again a very painful process, right? Imagine if your report is connected to two or three different data sources, you have to go and manually update these data sources when you go from dev to test to prod. So There is limited automation, as I said, currently. And then it's again costly to have a PBI, a premium or fabric capacity license. So with all these challenges, Microsoft has, taken note of these challenges and has come up with something known as a PBIP. Now, before going to that, this is the out of the box deployment pipeline. I just wanted to show you how it looks like. Now, unfortunately, I can't show you my client environment, but I can show you. I mean, that's why I'm just showing you a screenshot, minus all the sensitive details. So this is the out of the box Power BI deployment pipeline, which does the job for the most part, where basically you can go from dev to test to prod. But again, you have the same challenge with the PBIX here, where you can't, your developers cannot work on the same report without overwriting each other, without stamping over each other. You cannot have PR like the way we do with code, right? An automated PR, a merge process, pull request, merge, and check in. This is just a manual process, but it's still good because you don't have to change your. I mean, you can specify your data conditions where you can basically, when you go from dev to test, you can have you have conditional formatting and rules where you can modify your connection strings on the fly, which is what I like about it. We've been using it for a bit, but again, this also comes with um, a very big negative, which is you need a premium capacity license for your workspace, which is again very costly for a majority of companies. Um, and then that is a premium capacity per workspace. So imagine if you have 10,000 workspace and you have $5,000 per month per workspace, that's a lot of money. To mitigate all that, we have something known as a PBIP, which is nothing but a Power BI projects file. So imagine a C#.NET project with a CS proj file, right? It shows you all the bits and pieces inside a project or a solution. So that's exactly what it is in the Power BI world now. This is still in a preview feature. It's not yet rolled out. It's not like generally available yet, but essentially the high level here is that it's a new way to manage and deploy Power BI content. It encapsulates all the components of Power BI project, which I'll go through in a bit, including data sets, reports, data flows, things like that. It's like your single source of truth for a Power BI projects. Simplify the deployment process through something known as automated CI/CD pipelines. Um, and basically the biggest benefit that I feel it is that it enhances collaboration between the team members. So I can create and another resource can create this, can work on the same report, which was not possible otherwise, with this PBIP approach. And that's why you can collaborate with multiple teams across your organization. If you're working on the same report, I can work on page A of the report. You can create another page B, and can have multiple reports in the same dashboard. Um, Integration process is easier with CI/CD. There are a lot of Fabric APIs that Microsoft has created specifically for this, and there's also a GitHub project which we have referenced and we have built on top of that. I'll go through that in a bit. But again, as I said, these are the key features that the PBIP brings to the table. One is a version control, collaboration, which is the biggest benefit, automated deployments, which is like no touch. You don't have to just you just have to write reports and not worry about deployments at all. It's all can all be connected to your Git repository, and it can all be done in an automatic fashion. All the semantic model updates can be also done in a automated fashion here. When I say semantic model, it means that if you're using direct query, if your developers, Power BI devs are using direct queries to your data set through a semantic model, you can always go from dev to test to prod without rewriting or without doing anything there, with just one, with the YAML deployment, basically. Seamless integration with CI/CD pipelines. We'll go through that in a bit. Again, these are all the slides that probably talk about the same things. The biggest benefit, though, is that you don't need a premium capacity license to do this, which is great. Things to do to test or get started with PBIP: install the Power BI desktop. Of course, that's the first step. Enable the PBIP feature, which I'll show you in a bit. And then you can create a PBIP project file, which shows up as a drop-down value when you try to create that PBIP project. But you have to enable it for now. It is not available by default. You have to enable it through the preview features, and then add your Power BI reports and data sets to the project. So I'll just show you this, show this to you in a bit right away. So if you go to this is a Power BI desktop project. Go to options and settings, options, and this is just a sample report. You go to the preview features right here, and if you see my screen here, there is this Power BI PBIP save option. Once you enable this, and the semantic model is a TMDL format. Once you enable all these three checkboxes, you can pretty much save this file, which is a PBIX file, as a PBIP file. Watch. So you see, if you do this, it actually creates these two additional folders. I have already created them, but I can delete them and show it to you again. Yeah. So once you save this, and you can rename it, things like that, as a PBIP, it basically creates the metadata of this report, which is a human readable format versus a garbled format. And I'll take you through the metadata as well. So if you see, it divides the reports into semantic model and report. Now you have the option to import data in a Power BI report as a Power BI developer, or connect to a semantic model. It works for both the scenarios. In our organization, majoritarily we rely on creating a semantic model and sharing it across the teams, and then having them doing direct queries instead of importing data. Just as a standard practice in our company. So again, the semantic model is a PBISM format, and the report is a PBIR format. So these are the two distinctions here. In this case, this report has both the data and the report. So that's why we have these two folders created. Some of the reports in our organization just are report files. So we just have a PBIR file created. And then in the definition, if you see, these are all JSON formats. So if I open up one of them, show you, this is a very simple human readable JSON, depending on what your report is doing. Now, if you go to the semantic model, probably that's your best bet to see what tables and things like that associated to that. So if you have a table there, TMDL is your model file that you can look at. Things like measures that you have created on the table. So if you're aware of measures, they are nothing but DAX expressions that you can create and build your data sets and build your reports using those DAX expressions. So it could be aggregations, it could be summations, it could be count, it could be joining different tables in your data set for presentation layer or for your reports. And then you also see the columns associated for those reports and tables, things like that. So this is pretty handy, I would say, from a development perspective, where you can collaborate and see what changes have been made. If someone is overwriting your measure, you can immediately catch that in a PR review process and merge and do the merge process that way, right? So these are some of the good features. Now there's also model.tmdl. This will go through here real quick. Essentially, it shows all the tables associated right here. Now, this is a small data set. This is not a big data set. I have a model, a TMDL file with hundreds of tables there, which then adds a lot of value when you have so many developers. There are 5 developers working in the team, and modifying the same semantic model daily. This is where the whole benefit comes into picture, where you have so many changes in a day that you want to moderate them and manage them without stepping onto each other's toes. So this is a great example of that, the PBIP file that helps you do that. Moving on to the next slide here. Now, again, I showed you this process just now, and this is the structure of that file. So I'm not going to repeat myself. I'm just going to be the next slide here. So yeah, the TMDL format, we went through that. Again, if I can zoom in a little bit, yeah. So this is an example of a model that basically shows easily readable and understandable Power queries and DAX expressions, things like that, right? The table names, the column names associated in the TMDL file. In the past, it was TM. I mean, you could also have TMSL, but I prefer TMDL. It's like table model definition language. It stands for table model definition language. You can open that whole project in a Visual Studio Code or a Visual Studio standard product. And essentially, you can create a feature branch, and your individual developers can create their own respective feature branch and create PRs that merge to the master. And all this experience can be done through the Power BI desktop. You don't have to write code to create reports. It can be done through the Power BI desktop. You save it as a PBIP in your Git repo, and then you can create a feature branch using that. So it's all very seamless. If you have worked with the Git repo or ADO Git repo, and if you work on .NET projects, this is pretty straightforward. There is a little bit of learning curve if you want the citizen developers like business folks to write these reports. Yeah, there is a little bit of learning curve there for sure, which we are encountering right now because they don't have a lot of information on how to create feature branches and things like that. So we are training a few of our citizen developers on creating PBIP and converting their existing PBIX to PBIP. Again, same thing, version control with Git. It's compatible with the standard Git and the ADO Git repos. Initialize a Git repo and create a feature branch, create a PR, and then merge your changes to the PR. Everything is the same process if you're familiar with the ADO repo. Yeah, it's the same thing. Additional thing is on the back end, in our bicep and YAML files, we have some PowerShell scripts and Fabric API. We call the Fabric APIs to publish your reports or semantic model directly to the workspaces that you care about. We also have something known as what we have done here is we created a manifest file to configure everything in one place, and then the process automatically looks at the manifest files and does the needful. So what I mean by that is if you have multiple environments like dev, test, prod, you can configure that in the manifest file. And if you have multiple reports, it basically iterates through all the PBIR files and PBISM files and deploys them one at a time. And you can also configure your manifest file in such a way that you tie individual semantic models to individual environments that way. So that's pretty handy. Now, this is an example of a workflow that I was talking about earlier. And on the right, you see that this is how the data set, the build pipeline looks like. When you publish it, when you merge your changes, the build pipeline kicks off. Then you can, basically the best part about it is you can also add rules that your developers can adhere to. So if you have 5 to 6 developers, and you want to enforce constraints, or if you want to enforce rules on how they write measures and naming conventions, things like that, you can enforce them in the build process itself. There's also a PBIX inspector which you can configure, which we want to avoid that specifically because it's not very friendly. But you can enforce that if you have specific rules for your data set, right? And then there is also a sample Fabrics PBIP project that you can definitely refer. I have a link here which I want to share real quick. Here we go. This is that sample project that we had started off. This was very helpful to begin with. It also has resources like how to deploy it. I mean, this is the PSM1 file that we have used. There is also a bicep file, I think so, associated to it that we had to refer. See if there is one here. Yeah, so we pretty much went through that PSM1, and then we had a bicep file and a YAML file associated with it. But basically, this is a PowerShell Fabric PSM1 file that calls the APIs to do the needful, and you'll have to configure permissions accordingly. I worked on the DevOps side of it a little bit, but it was primarily my DevOps engineer that helped us out, basically, when we got stuck somewhere. Again, the best practices, use meaningful commit messages when you are committing your PBIP project files. You update it regularly, depending on your needs. Test the deployments and then monitor the deployments. Now, again, I want to go back. If you have any questions at this point in time, I have a resource for you, which basically it's very, very helpful. When we got started initially, what's that resource? Yeah, this was the one, I guess. This is very helpful. This was very helpful for us initially when we began. We went through it step by step and understood the changes. So this is a good place to start if people have not got started here yet.
Mehul, can you put the link into the chat for that?
Absolutely, sir.
That would work good. Yeah.
Absolutely. I'll just do it right away. Any questions so far, folks?
Not yet for me.
Yeah. A common
I have a feeling we
question.
could probably have you back and maybe do a full-on session on this. I think you probably have enough content to probably fill an hour.
Oh yeah, you're right. I mean, I think I might be over 15 minutes. It's not a lightning talk anymore.
Yeah, that's fine. But yeah, if you want to flesh this out more, and we can maybe arrange something this summer, and we can do even more on this. I think this is all
Yeah.
great stuff. So I definitely
you.
know I have people that would be interested.
Absolutely, we can do that. Yep. I'll have to put something together for you guys then. The last, and I can wrap up pretty quick here. I mean, this is what I'm excited about, the Fabric, One Lake, right? And I'm sure people have attended the Fabric conference, and I found a lot of value in what I saw at that conference. And there's also a project that I have configured. I don't have time to go through it. It's a lake house, right? It's like my dummy project that I've created, but it's like the cool part, which I want to just show real quick before I let you guys go, is this real-time dashboard feature, right? It basically infers your there's a one where it would infer your data set. So I have a crime data set right now, not the one, but there was a one that would basically infer your data and create automatic reports based on that. Yeah, here we go, interactive presentation. So you pick your semantic model, and it automatically generates visuals for you based on the data set that you have. It infers the meaning and creates the data reports, and visuals according to the data set that you have. So watch this. So area where the crime was committed, right? This is a Los Angeles generic data set, and then the time and things like that, right? Uh, Now you'll also have to go and make changes to the visuals, but this is a pretty good start, I would say. So I will leave you to that. But if you have any questions, feel free to reach out. Joe has my email, so we can circulate that as well. If you have questions, if you are stuck somewhere, I'll be happy to help. Thank you very much.
Thank you.
Yeah, thank you. No, very nice presentation, and yeah, we'll put this link also in the meetup comment section as well. And if you have anything you would like, you can always comment in the meetup comments as well with your contact info if you want to put that there as well.
Absolutely.
It's up to,
I'll put my LinkedIn and my email. If people want to reach out, feel free to reach out. I can help them out. Thank you.
Excellent. Thank you.
This is really good to know. I didn't know this was coming, so it's really great information. Thank you.
Joe, are you talking?
Sure.
Because you're really quiet.
I said I think this is really great information. I didn't know this was coming, so it's great to know. As a developer, I really appreciate the ability to get some source code tracking involved in Power BI. So really good to know about. I have to admit I was not informed, so it's good.
Yeah. Thanks, Joe.
Well, Jeff, without any further ado, if you want to do your thing, you're next.
Alrighty, I'm going to start sharing. And hang on just a minute. Teams has got to ask me 32 different times what I want to share. And so let's try this. Can you see all that now?
Yes.
Okay. Very cool. Alrighty. Well, let's get started. First of all, I do have an abstract that I include in this at the beginning of the actual presentation. And I have to tell you that when I committed to this particular presentation, I didn't have it written at all. And I thought I could have it fully done, but I have a little bit more work to do on the actual PowerPoint presentation. I have all the information that we're going to do, but I have a little bit more information that I wanted to include in the PowerPoint presentation. And so I'll have that ready for you here in a day or two, just like Mike said with the recording. And speaking of that, this is a glass remote presentation, and this is the 23rd of April. Mike, how many years has this been now? You know, I'm sorry to shotgun you here.
Oh,
Was it 2015 that we started?
15 or 16. We got to be right here pushing 10 years. Tell you what, I'm going to do a little more research quick and see if I can determine that, because we got to be close to 10 years.
The really cool part is Mike and a couple of other people got a hold of me and said, are you interested in speaking for our group? And I didn't realize it was going to be a brand new group. And I said, absolutely. And so we started kind of a tradition with me speaking in every April. And I've only missed that once, and I gave up the spot to have a new speaker start speaking. But I've been the April guy for either 9 or 10 years.
All of our documentation that when we first formed the group is saying April 2015. So happy 10 years to us.
Actually, this would be the 11th meeting then.
Actually, yeah, it would be, wouldn't it?
Yeah.
Okay, so 10 years last year. We forgot. Anyways.
Yeah. 10 years in time, 11 presentations. All righty. So this is fun. And like Mike said, GLASS stands for the Greater Lansing Area for SQL Server. And I actually was given one of these glasses way back when. So thank you guys for that.
Everybody has one but me. I gave mine to somebody else and I never got another.
Oh my, that's too bad.
Yeah, that's all right.
I would have kept it. I would have said, sorry, sucks to be you. This is the last. Have it.
That's okay.
Anyways, we're going to properly convert DateTime2 to DateTime. And, you know, a lot of people have asked me, why in the world would we need a presentation on this? And Mr. Owen Price, who is a bit famous over on LinkedIn, could tell you why, but I'll tell you instead. First of all, it's one of my basic tests for AI. AI fails this test. It does not know how to properly convert DateTime2 to DateTime. The reason for that is because AI is a bit of a consensus engine when it comes to things like writing code. And if you ask people out in public how to convert DateTime2 to DateTime, you'll find that the consensus matches AI. They don't actually know how to do it correctly. And the really bad part is, if you go and look at the Microsoft documentation, which we'll see a little bit later on, they don't know how to do it either. In fact, they've recently made some changes that are actually incorrect, and we'll cover a couple of those as well. But the other thing is, a lot of people don't understand the reasons why you might want to convert DateTime2 to DateTime, and we'll cover those as well. My name is Jeff Moden. Here's a little bit about me. My public email address is up here. It's jbmoden@gmail.com. And if you want a copy of this presentation, and you know, it'll take me another day or two to finish up the PowerPoint on this, but if you want a copy of this presentation and the code that goes with it, send me an email. And I'm one of these people where I say, you know, don't worry. I am not trying to collect your email address. I will not use it for anything else. And in actuality, once I've verified that you have a copy of the presentation, excuse me, I'll actually delete your email if you want. Here's a little bit more about me, and you can read that on your own. For those that are interested, I was an SQL Server MVP for 9 years in a row, and then I quit doing that. But I am the fellow that coined the term rebar, and yes, it is pronounced rebar with an E, and you know, it doesn't have an E in it or a part missing name or anything like that. But the reason why I pronounce it rebar instead of R-bar is R-bar sounds like a friendly place where we could go and have a drink together, whereas rebar represents the metal rods hopelessly stuck in cement forever and not going anywhere fast, just like rebar code. I also help make the tally table household name. You might know it as a numbers table. And Itzhak Ben-Gan came out with his getNums function, which is cascading CTEs, and that's my name for what he's done. Cascading CTEs to make his getNums function. And I came out with an fntally function, and it's a function. The reason why I called it, I normally don't use Hungarian notation to begin with, but I maintain a separate tally table, and you can only have one thing named tally. And so I said, okay, I'll use Hungarian notation on this. And it's a lot of fun, actually, because it's not actually, I'm an ex-submarine sailor, and I can score the chrome off a truck bumper as it drives by at 80 miles an hour. And so I wanted to have some fun without it being an HR violation. So fntally is just perfect, because I can tell people the reason why you're having a performance issue is because you didn't use my fntally function. And it's not actually an HR violation. So just to let you know, SQL Server is not only my profession, but it's also my hobby, and I do it pretty much to the exclusion of everything else, except for drinking coffee and breathing. And I found out that's the necessary order. So I know, yeah, I need to get a life, but I have a face for radio, so I'm pretty much stuck what I'm doing. Again, up here at the top, jbmoden@gmail.com. It's easy to remember my last name. It's I've had Moden enough of bad code. Alrighty, for questions, I'll stop at certain logical points. If your question is for in relation to a given slide or a previous slide, then please reference the slide number, which is down here in the lower left-hand corner. And the session goals, I haven't really finished these yet, but they're pretty much to give you an idea of all the reasons why people like me love DateTime, and then how to do the conversion, and why you really need to learn how to do the conversion, because it's full of pitfalls, and there's a whole lot of warnings about the DateTime2 and DateTime offset data types that most people really aren't even aware of. It's a real problem, and there's a real problem with implicit goals, and we're going to learn more about those implicit conversions that can really put the screws to you. So why would anybody want to convert DateTime2 to DateTime? In order to do that, we have to, or figure that out, we have to do a little comparison first. So we're going to compare DateTime2 to DateTime. There's some references, and there's a reason why 1753 is the first date for DateTime. Any date prior to that is not accurate because of the Gregorian calendar. The United States and Great Britain started using the Gregorian calendar back in 1752, which was actually prior to the United States becoming the United States. So there were like 10 days missing in 1752 because there had to be an offset to make the calendar catch up correctly. The Julian calendar prior to that wasn't working. And we actually joined late. It was the Gregorian calendar actually started, I'm going to say 300 years before that. And it was a little difficult to get the word out back in those days, but we finally got the word. Anyways, Connor Cunningham from Microsoft wrote a nice article on SQL DateTime and DateTime2, and it's been published over on SQL Skills, which is Paul Randall's site. Kimberly Tripp used to be there, but she has retired, that lucky lady. There's also a good general history on about the Gregorian calendar, and here's a wealth of information about the adoption dates. Turkey didn't actually adopt it until 1927, and I think they were the last holdouts on that. I think everybody else has done it. For other reference purposes, the Microsoft documentation on DateTime2 can be found at this link that takes you to the equivalent of Books Online. In online, it's the Microsoft Learn site, and the same thing for DateTime. There's also, if you type DateTime offset and you type in T-SQL after that, it'll take you to the correct site for that. Now, there are some legal ramifications that I want you to be aware of, and you can find those legal ramifications. I did a Perplexity search because it was convenient, and it also helped you test Perplexity on that type of thing. Perplexity is one of these sites that samples from ChatGPT, from Autopilot, and just a whole bunch of them. And so this is the link to that conversation that I had, and it has a ton of links in there. I think it's got 16 different links. So it is an AI response, and it looks pretty good to me. I'm not an expert at it, but it turns out that, basically speaking, it is never, ever okay in finances or pretty much anything else to round up to the next day in your calculations. And for a lot of things, as you'll find out if you go and you read about these things, it's getting to the point where a lot of people want things at the microsecond level. So obviously you would not be using DateTime for those types of things, because DateTime doesn't have Microsoft resolution, but we'll talk more about things. It has details about those other rounding issues, and we're going to actually prevent rounding up at the temporal unit at the millisecond level. And that's good for DateTime2, but you don't want to use DateTime if you're worried about the millisecond level. Alrighty, DateTime2 advantages over DateTime. They'll say it's got a larger date range. Okay, let's look at that. DateTime2 does have a date range from the year 1 up into the end of the year 9999. DateTime only starts at 1753, but we have that problem again with the dates being inaccurate prior to 1753. And so my recommendation is, if you need to use dates prior to 1753, don't use SQL Server to figure it out, because they don't have the correct offsets for any of the date times by country. You're going to have to figure that out. My other question is, who's using date times prior to 1900? Never mind 1753 in SQL Server. If you're using dates prior to 1900, you're in a very unusual job, because I've never heard of anybody having to do with finances, even birthdays, of having people prior to 1900. Also, DateTime2, higher precision, right? DateTime2 is accurate up to 7 decimal digits. That's 100 billionths of a second, or as they advertise, it has an accuracy to the nearest 100 nanoseconds, which is a billionth of a second. DateTime2, it's only accurate to the nearest 1/300th of a second. And to make matters worse, they don't give you 3.3333 milliseconds. They only give you increments of 0, 3, or 7 milliseconds. So we have that secondary rounding problem that we have to worry about. And you can learn more about that. I finally found the real old reference that goes all the way back to SQL Server 2005 that explains the 1/300th of a second. It also explains that it consists of 2 integers, where the leftmost integer, it's big endian. The leftmost integer is for whole days, the number of days since the epoch date, which is the 1st of January 1900. And then the right-hand side is a count of the number of 1/300ths of a second. And that's really interesting. And if you're going to get into some of the direct date math that DateTime offers, it's really, really helpful to know that kind of information. It also has DateTime2 has customizable precision and space savings based on that. For example, DateTime2 can have 0 to 7 decimal places for the number of seconds in time, and you can save 1 to 2 bytes for precisions less than 5. If you're going to use milliseconds, it's going to take 7 bytes, so you only save 1 byte. But if you can get away and use hundredths of a second, you can get down to 6 bytes. DateTime, on the other hand, is always 8 bytes. I don't ever recommend using small DateTime because it rounds up to the next minute at the 30-second mark, and it's only got a resolution of hours and minutes. It will display hours, minutes, and seconds, but the seconds are always displayed as 00 for small DateTime, so I'd stay away from it. They also say DateTime2 is better for standards compliance. It has more different time representations. If you look at cast and convert in the documentation, it shows cast and converts only out to 3 decimal places. It'll actually do out to 7 decimal places, and so it's a lot more compliant. But they don't document in the Microsoft cast and convert all the decimal places that can be had. And last but not least, if you go and look in the DateTime write-up that I gave you a link for earlier, Microsoft recommends that you avoid using DateTime for new work and instead use time, date, DateTime2, DateTime offset, and all those new things that came out in the year 2008. Alrighty, let me stop here for just a minute and ask if anybody has any questions. And Mike, I'm not looking at the chat, so if you see something come up in chat, let me know.
Nothing so far, but you were asking about people working in jobs that would be going back before like 1900 or so. I doubt they kept records to the second by any means, but work comp insurance originated with pirates. Like literal, like Captain Cook. You lost a limb or lost digits, you got gold as compensation. So they are the original work comp insurers. But like I said, I don't think Captain Cook was keeping records to down to the second.
I didn't know that though. That's interesting, and
yeah.
It's amazing that tradition continues.
Mm-hmm.
Alrighty, so to continue, with all those advantages that we have here for DateTime2, why would anybody want to use the DateTime data type? And the answer is we're old folks. We're familiar with it. I've been working with SQL Server since 6.5, and the other DateTime data types didn't come out to 2008. That's a long time. That was almost a decade for me. Backwards compatibility. One of the really cool parts about SQL Server is if you write something that works well, it lasts forever. And so you might have some backwards compatibility that you might have to maintain. And so you need to know how to use DateTime correctly. In other words, if it ain't broke, don't fix it. People won't necessarily want to go and spend the time to convert both the back end and the front end and everything else that talks with it to DateTime2 or DateTime2 offset. The other thing is that you don't want to mix DateTime2 or those other things with DateTime because of some of the problems that we're getting ready to talk about. Paul White did an excellent article on all the reasons why you don't want to mix DateTime with anything else. And we're going to cover some of those and a few more that he might not have even covered. But yeah, that is an article that's definitely worth a read. Another name is its handle on the internet is SQL Kiwi. A lot of people don't know this, but in 2016, remember all the promises of it just runs faster. Yeah, it also came out with some breaking changes for DateTime because they decided that they were going to try to make it more accurate. And in their making it more accurate, they made it so it was no longer compatible with DateTime. And here's the link for that kind of information. Again, you don't want to mix DateTime2 with DateTime. You do a full-up conversion. Another reason for using DateTime is it was written with some great forethought. You can use simpler date math. For example, if you want to add a day to a date time, all you got to do is say +1. And because of the date serial numbers behind it, it works. And it works well. And there's other things that you can do with it. For example, if I wanted to add 5 hours, 47 minutes, and 30 seconds, I could actually type in 05 colon, et cetera, for the date and the time as a string and add that to date time, and it would work. I don't have to do all that other stuff. It's also easier to prevent implicit conversions in formulas. If you do DateTime2 a lot and you do things like date diff and date add, you might not realize that you're doing implicit conversions there. And in certain, shall we say, edge cases, which aren't as edgy as you think they are, it will give you the wrong date. It may give you a date that's actually in the next year. So you have to be really, really careful. Even if you're just using DateTime2 by itself, it may go through an implicit conversion. I covered that in one of my articles on SQLServerCentral.com about how to convert Unix millisecond date times to DateTime2. The other reason is, and this is something that Paul White touched on in his article, most people don't know it, but date time, it can be a hell of a lot faster than DateTime2, and we will cover that as well. But it's especially where date add is concerned, but it's not just there. Alrighty. And what I'm going to do is I'm going to say, if you have a question, put it in the chat, and hopefully Mike will hummerock at me if there's a question. I'll still stop. And so I'll ask it, are there any questions yet? And
Nothing yet.
Yeah. Okay, thanks. So just to summarize some of the breaking changes of 2016, this is where precision becomes imprecise. And if you look up here in the upper right-hand corner, it says demo. And if you see demo, if in my normal presentations, it's either going to say demo, where I'll actually go to SQL Server and run a demo, or it might say code. But in either case, you can get the code from that file name in the zip file that I provide. This file name kind of wrapped a little bit, so it's kind of long. But yeah, it's there as a file name in the zip file that I'll provide. And one of the things that I didn't get to do was in a lot of the demonstrations near the end, because I ran out of time, I don't have this in there, and I don't have a nice numbered name yet, but I will have in a couple of days. Alrighty, so we're going to build the DateTime database. And let's just go over there real quick. And there it is. So go over here, and I'll just execute this. And while it's doing that, one of the things is the database name that it creates is JVM_DateTime. That's not me being a pompous or arrogant ass. I'm just thinking, okay, I want to drop a database and rebuild it. The chances of you having a database with my initials in it at the beginning are slim to none and left. But this creates a database. It's a simple recovery model. And this is SQL Server 2017 for the compatibility level. And I try to keep things small. It's actually at 50 megabytes. And this code is included and fully documented. There's a couple of other things that go along with this, and that is, first of all, you will only see this, and I'll get to this here in just a minute. You'll only see these two things if somebody else is in the database. So it's an undeniable kill of the database, and so this forces rollbacks for other people. But it also creates one of my versions of the f_and_tally function, a thing called phys_stats, which allows you to look at the results of sysdm db index physical stats without having to look at all the columns. and it has a function for working with the compatibility level. And the reason why we need the compatibility level is so we can see where things went wrong in 2016. And so let's go back over here. And we went through all this. And yep. So all those are in there. And then we're going to create a view called breaking change, breaking change. And that's in script 200 here, which I already have up here on the screen. And I'm just going to create that. And it, if I don't have anything highlighted, it drops it and recreates it. I put the list of compatibility levels here just for your convenience. And you can see I've got this view, and I do a check in compatibility level 120, which is SQL Server 2014, and then I do the select again in SQL Server 2016. And what that view does is it hard codes these three dates and times, and then it will go and do a selection. And the only thing, if I don't change anything in this code itself, in the code below, I say, okay, I'm going to run the code to change the compatibility level to 2014. And then I run the code to select from the breaking change. And then I change the compatibility level to SQL Server 2016. And I run exactly the same code. There's no magic here. And what we get for the output shows you exactly what's going on with this. And let me, because I don't remember, I think I have all that here. I went through all of this. Like I say, I haven't given this, this is the real key here. All I'm doing in the view is I'm doing a convert, I'm converting some date time to DateTime2. And down here, I'm doing a different type of conversion. And I'm sorry, this gives us the sum date time with the conversion. And then we're checking to see if the date time and the DateTime2 are actually equal or not. And what we get okay, we don't have to go back over there. This is the code that I just showed you about running these, and identical code except for the compatibility level. And then the results, and again, that's from that same code. So if you take a look on those three dates, the sum date time column is the original date and time column. And converted to DateTime2, you can see they're equal when we do a comparison. This one, the DateTime2 has a bunch of extra zeros after it, but if you do the comparison, they're equal. And I got to remember, I did a hell of a lot of work here. If we look at 2016, which is this compatibility level 130, again, we're using the same date times, but look what happened to the 3 and the 7. They got converted to the literal 3.3333 milliseconds, and 2 times that gets changed to 0.0066667. They're not equal. The date time is not equal to its converted DateTime2 in 2016. And if you don't think that didn't break a lot of people, oh my God, it really hurt a lot of people that were interested in converting all their stuff from DateTime to DateTime2 because Microsoft said so. Any questions on this so far? All righty. All right, so some simpler date math, some direct date time math examples. The first of the year, first of the month, first of the week, other day of the week, a day with no time. There's a bunch of different calculations that you can do that might have implicit conversions in them. And I don't have a list of all the different code here for you. I'll try to get that put in later on. But a really good reason why people want to use DateTime is because of the speed advantage. And so let's start taking a look at that. Let's go over here to script 300. And again, we're going to make this work off of the JVM DateTime. And what all these scripts do, I'm going to start running it. And what you can see is it's going to create some test tables. It's going to create a DateTime test table that has dates from the 1st of January 2020 up to and not including the 1st of January 2030. And then it's going to just do a straightforward DateTime 2.3 conversion for a DateTime 2.3 table, a date table, and a DateTime offset table, just to show you the speed differences. And then this part here will go through using SQL variant, and it'll show you what the data types are, the max length and the scale that are actually in each one of those tables, just to prove to you what the data types are. And then we do test one. Test one is going to be to add 1 day to all those date times. And just as a reminder, there are 10 million dates and times in the table. Now, it's not a very big table. It's got 10 million rows, but it's a good test table. So we run through some code that will use the typical conversion. This is a typical conversion that a lot of people use. And it runs that 5 times to make sure that we get a good average. And then it'll do the same thing for DateTime 2.3. These are all date adds. And same thing for date, and same thing for DateTime offset 3. And then we have a little fun. We also do some direct date math here. And this is an example of direct date math. This is the same thing as doing a date add of 1 day. We can just pump that in. If you wanted to add 12 hours to a date, what's half a day? 0.5. You know, and so that'll work. And then we do the test 2, which is find the first day of the week, and I did it for Monday because it's convenient. The 1st of January 1900, which is the epoch date where the date serial number behind the scenes is 0, is also a Monday, and that's kind of convenient, especially for the people over in Europe, because they use Mondays as a lot of them use Mondays as the start of the week, where in the US here we use typically Sundays. But what we do is we use a date diff based on the 1st of January 1900, and that gives us a certain number of days. Then we do integer math, and we divide that by 7, which gives us the number of weeks since the 1st of January 1900, and it drops any of the remainders. And then we do more integer math and multiply that by 7, and that gives us the number of days that those weeks represent. And we do a date add to the 1st of January 1900, and that gives us the first day of the week, whatever that date time was. It'll be the Monday that we're converting. And then we do the same thing for these other different data types. That's for DateTime2, 3. This one is for date. It works. This one is for the DateTime2 offset. And then we do a little trick here. We use 0, which is the date serial number for the 1st of January, 1900. And this can work depending on how you hold your mouth. Here we're doing a date diff with the date time, and then the same other calculation, and then a date add. And people go, what's the difference there? You'll see it. And then test 3, and I'm not going to run you through all of these, but test 3 finds the first day of the week using a variable instead of the literal string. So we create a variable. I call it at 1900. Most people don't know that you can have a variable that starts with a number, and at 1900 is very convenient. And I just start it here and say, okay, I'm going to use that as a date time. And instead of using 0 or a literal in the calculations, I use that at 1900. Same thing with these other ones. Exactly the same calculation that was used before. The difference here is the variable is defined as the correct data type for whatever I'm just trying to demo here. And test 3 goes through all of that. And then finally we do the date time with a 0. There won't be much of a change here because it's done once in a variable and then used. And so what do we have for an output? And the answer is not much there. I'm sorry. All the output is over here in the messages. And you can see I do the logical reads in the whole 9 yards, and I do the CPU and the elapsed time, and it does it for a run of 5 times for each one of these. And then it starts the next test, et cetera, et cetera. And I'm not going to run you through all of that, but it is fairly extensive. And let's go see if we can see something a little easier to understand all of this. And so here's test 1 for adding 1 day. And you can see the labels here. Let's see if I can do this. I haven't done this kind of a presentation in quite a while. Yeah, you can see the labels here for each test. We have a date time, we have DateTime2, 3, we have a DateTime2, date time offset with 3, and then the date time, the DDM there stands for direct date math. And there's DateTime2, 3. And over here is the date time using the direct date math. And that is substantial. That's a substantial difference right there. Instead of taking 1.6 seconds, it took less than a second, 934 milliseconds. So in this case, that's 42% faster than date time. And again, we're only using 10 million rows here. And then we have our second test for finding the first day of the week. And very similar, there's the DateTime2, 3 run, and here's the date time. And again, it's 39% faster. And the first day of the week, which was using the variable, there's the DateTime2. And I did something wrong here. I copied a wrong graphic here. It was substantially faster, but it did turn out to be about 37% faster. I got to correct that one graphic. So another reason why people like DateTime is it also makes it easier to prevent implicit conversions in formulas. And let's go take a quick little look at that at script 305. And what we have here is some simple formulas. And you'll see doing a simple conversion from the DateTime2 table. It will, and I'm just doing a top one to show you that what's in the DateTime2 table is in fact the DateTime2, and I didn't put the scale in, but it's a DateTime2 and the base time is a DateTime2. And here we're doing we're still using the DateTime2 table, but here we're using some of that direct date math that I told you about. And here's a famous example. This one is using the literals that everybody says, you got to use the literals instead of the zeros. Okay, we're using literals. What's that going to do? And then we show you the fix, and you'll see what I mean by the fix here. If we run this, we can see, okay, we started off with a DateTime2, but this right here changed it to a DateTime, which means that it's subject to implicit conversions, which can end your life as a professional. And then, okay, let's do things the way people want us to legally do them. Use the actual literal for the date, okay? That also produced a DateTime because date add here, date add is stupid. It looks at this and says, oh, okay, there's a literal there. Okay, I'm going to use DateTime. And so converted it to a DateTime. And if you want to actually avoid that for the date add, we still have a date add, but in order to get around the problem of the implicit conversion, we had to do this. And you also find out that if you use at 1900 as a variable, that will also allow you to take the place here. But this is the kind of implicit conversions that bite people on the face. Here, this looks totally correct, but it's not. And it will kill you on some of the conversions. And I'll show you some of the kills that it does. And again, this is the example of the DateTime. And I just want to show you that we're going to run the code that we did above with that variable, just to show you that it's a simple way of keeping the calculation from doing implicit conversions and keeping it at DateTime2. Now, in 2025, it just amazes me that it came out with DateDiff big to try to make up for the mistake of not being able to do direct date math. I have an article, for example, that shows you can take an end time and subtract a start time from it using DateTime, and it will actually correctly calculate the duration right down to milliseconds if you want it to. Or you can use it to create large durations. In other words, hey, I've got these 15 different projects. I want to add up the time one right after the other to come up with a total duration. You can do that very easily with DateTime2. And that's some of the other things that we mean with simpler date math. And there's 1,000 of those things you can go look up, but that's why a lot of people want to do it. Alrighty, any questions here on the implicit conversions that this causes? Okay, I'll take that as a no.
All quiet in the chat.
Okay, thank you. All right, so let's go back to here. And we saw those and we went through that. And, you know, there's our original. The implicit conversions occurred. That sucks. And here, it took some form of extra code to keep the DateTime from going into implicit conversions for some simple calculations like calculating the beginning of the week. And that's why, that's another reason why people like working with DateTime. You don't have to put up with the implicit conversions. Alrighty, so another speed advantage. This would be script 310, which I happen to have up here. And basically, what we're going to do is we are going to do some aggregations. And all we're going to do is a sum grouped by month. And we're going to do it for date time. We're going to do it for date time with optimization in the group by. What I mean by that is, you know, calculate for the first of the month. And it just amazes me that Microsoft made an end of month function, but they didn't make a first of month function. And I'm going, what is wrong with you people? Good Lord. So to calculate the first of the month, you can do the date diff based on month, and then do a date add based on month, and that will give you the first of the month. And then you can do the month total with a sum, and you need something to group by. So most people will group by exactly the same thing that they have to calculate the monthly date and time. And that works. There's no question about that working. But there's an optimization that you can do. Remember I said date add can be a little slow? You don't need to do the date add. The purpose of this date add is to turn it into a human readable month. All SQL Server needs to know is the month number that is calculated by that particular formula. And so if you just do that, you get a hell of a speed improvement. And so that's another little trick that you can do. And it doesn't matter if that's DateTime or DateTime2 or whatever. For these types of aggregations where you're trying to do things by month, your group by doesn't have to be by the display month. It just, this calculates the month number before it flips it over using date add. And so it does all these things, and I'll just, and I gotta not have anything selected, and we'll run that. And I meant to run it while we were doing it, but it goes through and it does all these calculations over and over and over again, using each of the different data types that we talked about before. And over here, it gives us an output. And again, we have the different names that we can use. But one of the things I want to point out is the OPT notation up here, like on DateTime OPT. That means it's got the optimized group by trick that I just showed you. The INP on some of these means that it made an implicit conversion and you shouldn't use it, but I included it here just so that you can see some of the differences. So without the optimization trick and group by, even DateTime has a little bit of a performance problem. And yes, that's 18.7 milliseconds for this, for the CPU, amount of CPU. Obviously, this one massively parallel. And it took 2.3 seconds to generate the little report on average. Date from parts. A lot of people go, date from parts is the ultimate in speed. No, it's not. It's not. And, you know, you just got to prove these types of things to people. You can't just state, well, in my opinion, it's really fast. Like that one guy said, if you don't have data, then all you have is an opinion. DateTime was seriously optimized when it was made decades ago. Like I said before, people really put some good work into it, and it shows right here. This is DateTime2, DateTime2.3 optimized. It took almost 8 seconds and 735 milliseconds for duration. Look at DateTime. It's that's what is it? 5/8. So it's about 6.25, 0.625. So is that 28 or 30% faster than this? I forget off the top of my head. But DateTime optimized, yeah, it's really worth going for. These other ones, the DateTime2 offset 3, that's the same as the DateTime2 over here, except it's offset. And these other ones have the IMP in it, the implicit conversions, and you got to not use those because you could have stuff changing places by year. Alrighty. So again, why would anyone use DateTime data type? Here's what we saw before. And the things in red are really important. It's easier to prevent implicit conversions in formulas, and there's a serious performance gain to be had. And that's especially, but not limited to, where date add is concerned. Alrighty, so the mistake of implicit conversions, we keep talking about that. What happens when we do implicit conversions? All right, and the answer is you get sued. So very simple question that I asked AI is how to convert a DateTime2 value to a DateTime data type. And I also asked that question of Google and a couple of other search engines, and they all came up with the same answers. And basically it was, hey, all you need to do is use cast or convert, and Bob's your uncle. I finally trained, it took me close to a week, but it took me a week to train the free version of ChatGPT to at least say there's a mistake, but it still gives you the wrong answer. On the Microsoft side, it also has a problem. This link here is the link that I gave you before for the link to the DateTime data type, except within that, they have a thing that talks about how to do conversions. And so you have to scroll down a little bit, but you'll find the following conversion. And if you look at right here, this is a kind of implicit conversion. It works almost the same as an explicit conversion. We take our DateTime variable, which was defined up here, and they're using DateTime2.4 to try to explain something. And then they are implicitly converting that to a DateTime2, or a DateTime rather, by assigning the DateTime2 variable to DateTime, and then they come up here and they say, yep, when the conversion from DateTime to and the date and time are copied, when the fractional precision of the DateTime2 value is greater than the 3 digits of the date time they're trying to imply here, but they didn't. They say the value is truncated. The value is truncated. Okay, not true. Okay, truncated, false. I don't know what but they pulled this comment out of, and I'm sorry about being angry about this, but it used to be properly documented where they said, hey, if you convert a DateTime4 to a DateTime, it's not truncated. It's going to be rounded, and we'll prove that. But here's the rest of the example, and we're going to grab some code for that. And I don't have the code in the upper right-hand corner here, but here's their code, and I just reformatted it so to make it a little easier to read, but I didn't make any changes. We even keep the same date and time that they used. And this shows the results on my machine. And if you look, this is the from date time. Why would they put from on the right instead of on the left? But they did. So there's the from, and you can see it's got the 4 digits of precision from the DateTime2.4. And here's the to date time. And everybody looks and says, okay, we got 0.123, and here we have 0.1237. Oh my God, it worked. It truncated, right? Yeah, right? Right? No. You probably don't see the problem, and most people don't. And I didn't for a long time. And then I got bit one day. So does it truncate to 3 decimal places? Let's work on that answer. I changed the date and time up here a little bit. I changed it to 9984. Now, because of that 4, it shouldn't round up, right? So we are still going to convert this to from a DateTime 4 to a DateTime. And if you look here, we have the 0.9984, and then look over here. Look at that. It's all zeros. And oh my God, it's not only the next date, but it's the next year. Okay. That's not truncation, folks. That's rounding. Now there's a double rounding going on here. It turns out that 0.9984 is the lowest 4-digit number that will still round up to the next year. But any date and time that has milliseconds of 8333334 will round up to the whatever the next values are. If it's 83333, it won't round up. It'll stay at whatever the milliseconds are here, and that means it won't ripple up through all of these other dates. So here, if an implicit conversion happens, you could end up in court. And worse than that, if your grandma makes a late payment, makes a payment right around then, and it turns out that because of the implicit rounding, it looks like that she paid a year late, be out of granny's will. So make sure that doesn't have to be your granny if you're working. Any questions here so far? Okay. Does reducing precision do a truncate? In other words, hey, if we have a DateTime 2.4 and we convert that to a DateTime 2.3, surely that must truncate, right? All right, let's go take a look. I again made a change here, and the 8.4 won't round up for this. But let's try this 9.5 and see what happens. Okay. And again, instead of doing the conversion to DateTime, we're just doing the conversion to DateTime 2.3, and we're just dumping the DateTime 2.4 value into that, and it does a conversion. And if you look here at the original DateTime 2.4, we have that time. And if you look over here, we have the same problem. Get rounded up to the next date. Obviously, the Microsoft documentation is incorrect. It didn't used to be. It used to say it's going to round, but they don't do that anymore. So be very careful in the documentation. And just as a little bit of a sidebar, people say, Jeff, why don't you tell Microsoft that they're wrong, and you can update those things. And you know what? I am so tired of doing that for Microsoft. I'd rather teach people like you that they made a mistake. I may eventually tell them, but I don't know. I'm having too much fun with them and AI. So the answer is to the question, does reducing precision actually do a truncate? And the answer is no. It actually does rounding, and that's really bad, as we've seen. I mean, we went from, and this happens more than just the year. It's going to happen at the tens of milliseconds, the hundreds of milliseconds, that can round up into the seconds rounding up, the minutes rounding up, the hours rounding up, the days rounding up, which means the months round up, the quarters round up, and of course, the year will round up. So there's a whole bunch of places where this rounding occurs. And like I tell people, a lot of people go, well, how often do you think that'll happen? It doesn't matter. I just proved that it can happen at least once. And this once will eat your face off in a court of law. So pay attention. you can't have this type of implicit conversion happening ever, not ever. Just don't do it. And this is why I also love the people in QA, because one of my favors of writing code is for me to test the edge cases, and it's the people in QA that say, start testing with the edge cases. They're going to tell you if it's going to work or not, and then fix it, because you won't get it right the first time, and they were so right. All righty. So I told you, I don't know if you like Bill Cosby or not because of what he supposedly did, but one of the things he used to do was he used to tell some great stories, and he taught this talked about this story with Fat Albert, and he told this one story, and then he said, "Okay, I told you that story to tell you this story," and this is the story where Fat Albert runs over Bill Cosby. Okay, so how to convert DateTime2 to DateTime. That was all that other stuff was a lead in to here. So there's multiple demos on it, and this is where I didn't finish, but let's go over to the code. And I'm a little, okay, so the other ones that I showed you, yeah, they were here. And I'll make sure that's in the documentation for all this included. Which one is this? This is another demonstration. And this one I'm not going to include because we covered it much better in the other ones. Oh, by the way, my favorite name for a scratch table that I'm using to demonstrate a very difficult thing is called Pound My Head. That's just fun. What the hell did I do with it? There it is. Okay. So we have a demonstration of multiple edge cases here. And what I did was, I just hand coded some things here. And I just want to show you, this is the edge case for the last value of date time that won't round up implicitly. And this is the first value that will round up implicitly. If you take 1 divided by half of 300, which is 600 when you're using fractions, you'll end up, and subtract that from 1, you'll get this number saying, yep, that's half of 1/600th of a second. And we also have the edge case for the decimal rounding. And then we have, of course, the last ones here. And if you run this, you get this. And you can see this is the original string date. This is the converted date time. And you can see in these, they rounded up really badly. And you can see that all the way across. And this was another example that I'm going to give you. But in order to convert from DateTime2 to DateTime, you need to do what they call millisecond truncation. All the other, all the Microsoft documentation said, yep, it does truncation. No, it doesn't. Let me show you how. Now, in SQL Server 2022, they finally realized that they were wrong, even though they didn't document it. And they came out with the new date trunc functions. And that is spelled like this, date trunc. And it has 2 parts to it. The first part would be, for example, MS for milliseconds, or you can spell out milliseconds if you want to. God, I don't know why you would want to. And you put the date there, and it will truncate it to whatever the millisecond value is. For example, if we look at 9985 way over here, the millisecond part of it is 998. The 5 was making it round before. We just want to truncate it at 998, and whether you're using date trunc or the method that I'm getting ready to show you for date trunc, whichever one you use, you can see it truncated it. The rest is all zeros, and that's the first step. So this Microsoft claim thing here shows you that it doesn't work the way that they said it does. It doesn't truncate. And so what we need to do in order to do the actual truncation, a lot of people have tried a whole bunch of different methods. What we need to do is we need to, for example, on this 99833 here, what we need to do is we need to take the 3334 and get rid of it. And the way we get rid of that is those are part, this whole thing is part of nanoseconds. You have to add 2 zeros here because it's based on hundreds of nanoseconds. So this is actually 9,983,334 nanoseconds. And so we've got to compensate for that a little bit. And so if we add 2 zeros here, we've got 4 numbers, 3334, plus the 2 zeros. We need to do our math based on 6 zeros. And so we do this, this calculation of nanoseconds, which gives us these numbers. And then we create the subtraction part by saying, hey, I want you to divide using 6 zeros and only give me the remainder. So you can see that leaves the 3333 plus 2 zeros here, etc. The 5 plus the 5 zeros, etc., on all of these. And then you need to add those nanoseconds, which are right here. You need to add those nanoseconds as a negative number to whatever you're trying to truncate, and that will give you the true millisecond truncation. That's not Microsoft, that's millisecond. True millisecond notification or truncation if you don't have 2022. If you do have 2022, you can use that, but this formula will work even in 2022. I haven't tested it yet, but I think date trunc is going to be faster than this long formula. And if it's not, then I may have to make a pork chop run to Redmond, Washington, and train some people on how to think here. And I'm sorry if that sounds nasty, but my God. So we have that information. And then once we have that, you can see that we've still got a little bit of a problem, because anything that is over that is going to round up to the next day. Well, the really neat thing is if we were to subtract 2 milliseconds from 998, we would end up with 996, and that will correctly go to the 9 for date time. Same thing with 9. If we subtract 2 milliseconds from that, that will give us a 997, and that will convert to a date time of ending in 997 for the milliseconds, and that is correct. And so what we have here, that's the right one. There it is. I'll include this in, and I finally formalized it. I'll include this in the zip file too. And obviously I never document anything, and I don't tell you how to use anything or anything like that. But here is the function, and what it does, just take you back to the top here real quick. Remember I said work with DateTime2 7. DateTime2 defaults to 7. If you wanted to put a 7 in there just because you don't like working with defaults, you could do that. But this takes some date time as a DateTime2 7, and then it calculates that, you know, what the number of nanoseconds are that we need to subtract, and puts a negative number in front of it, adds that to our original date time, and then we have to do that thing that says, hey, if, oh God, I'm sorry, this says, go look at this truncated date now, and if the last digit of the milliseconds is less than 9, we don't actually have to do a conversion. Just grab what we've got here and it'll automatically convert. We don't, if it's an 8, we don't have to worry about that because we're truncated at the milliseconds, and 8 is less than 833,334. So we don't actually have to do that conversion. So it says, hey, for only for 9 out of 10 examples, we aren't even going to have to worry about it. We can use this calculation directly. If it is 9, then it will subtract the 2, and that prevents the rounding. The 9s will come out as a 997 the way they're supposed to. And that's the whole thing here. And I just want to go up here and show you how to use it. So for a single value, this function is what's known as an inline table valued function. You can always tell whether a function is a table valued, an inline table valued function, as compared to a scalar function, which is horribly slow and will prevent parallelism, or an MTVF, which is a multi-statement table valued function. Both of those will have the word begin somewhere in them. If it doesn't have the word begin in it, then it is a high performance, or hopefully as you've written it correctly, it'll be a high performance inline table valued function. And you don't ever want to use, try not to use functions in your computed columns like Brent Ozar, and I did the verification testing for Brent. Don't use scalar functions in your computed columns, because any query that looks at your table, whether it's using that computed column or not, will not go parallel ever. You cannot have computed scalar functions in any of your computed columns if you want it to go parallel. Anyways, to do a single value conversion, you can just do this. We're saying select the converted value, and you put your expression here that you want to convert it from. So it'll be some DateTime2, and I should have the expression here and some DateTime2 mean the same thing. You're going to put a DateTime2 expression here for that first value. And you can also do the same thing for multiple values using a cross apply. Or it also works for outer apply if that's what you really wanted to do. And this is just a whole bunch of columns from whatever table you're getting information from, and then your converted value from this cross apply, and it'll be done. And that, ladies and gentlemen, oh, and I'm also doing some, I haven't finished the testing yet. This is writing to, it's reading from a 10 million row table or a 1 million row table, and I'm dumping the answer into a throwaway variable that I call the bit bucket, and throwing it away just to show you the raw speed for a million rows was 322 milliseconds and only 1.8 seconds worth of CPU. And for 10 million rows, it took 3.4 seconds and went massively parallel if you wanted to. It turns out that if you use a max stop of 6, it will drop this down to about 2.2 seconds instead of 3.4. And that's pretty much it here, folks. And I did go over time here a little bit, but I guess that's okay. Are there any questions?
I'll just wait for my brain to recongeal as normal.
I'm sorry about that, Mike.
No, no. I expect nothing less, Jeff.
Okay. Well, just to let you know, again, if you want to get a hold of me, there you go. Here's, yeah, come on. My email address is here in yellow. And again, I'm a full-time employee. So if you send me a request saying, hey, I want that stuff from this presentation, I can give that to you, but give me a day or two, simply because I read that email maybe once every day or two. It's not my primary email. And if anybody else has any questions, I'm here for a while.